That's number one on 6.1. Basically, you're solving the right triangle, giving different amounts of information. On this one, they say solve for x, but we're going to solve for all of them, all the angles and sides. Okay, so here's the triangle that they give us. Read that. It's 59 degrees, 15. This side is 15, right triangle. I want to find all the sides and the angles. So which trig function should we use to help us out? Now we're gonna need a calculator. I'm gonna have to open up Desmos, but let me go find one. 1 second. Okay. You have degrees, so make sure you are in degrees. I'm good. All right, so what trig function should we use? I think if I want to find this side, I think cosine might be best. So remember, cosine theta is equal to, we called it ca for the abbreviation, adjacent over hypotenuse, right? Do you remember? So that means that cosine of 59 degrees is equal to the missing side, which we'll call x, I guess, or we'll call it a and b. Okay, but I wrote that all weird. There we go. All right, so you're cool with how I set this up or where this came from. This okay? This setup?
Yes.
Okay. So that makes sense, and the rest is just algebra. This is the part that I need you to understand. How do we get this? If that's cool, then multiply both sides by 15. Do some algebra. So now this implies that A is equal to 15 cosine of 59 degrees. The question says to round to the nearest tenth. So that is 7.7. Does that make sense?
Yes. Isn't this what we did in Unit 1?
Mm-hmm. Yeah, we're kind of reviewing a little bit. We're just going to make it a little more complicated. And then we're going to go to something new. So if that's cool and you do remember, how would you solve for B then? What trig function would y'all use?
What we do a squared plus b squared equals 15?
Yeah, you could use it since it's a right triangle, you could use your Pythagorean to find it. That's totally fine. Oops, C is 15, right?
Yes.
Okay, so then B, skip a minor step, is equal to 15 squared minus 7.7 squared. Don't know what that is. So B is approximately 12.9. Okay, so we're going to use this to find B. And now we have all the sides, right? So if we call this um, angle capital A, capital B, and C, what are all our answers? Right? Let's write them all down. What is angle A? What is angle B and C? What is side A, side B, side little c? So in the exam, I want you to label your sides like this, and then your angles. They gave us B, right? But since it's a right angle, what is angle C?
90.
It has to be, right? And if you have two angles, how do you find capital A? That the sum of all the angles have to be 180. So do you agree that if you subtract from 180, you'll have
Yes.
angle A? What's that going to be? I don't know. 180 minus 59 minus 90, 31. So we solved the triangle completely, found all the angles and all the sides. So in the next, pretty much this entire first three sections of this, the majority of this chapter is going to be solving a triangle. So because it's a right triangle, we can use all the techniques we've used before. But once it's no longer a right triangle, you can no longer use Pythagorean, and some of the sine stuff doesn't work anymore. Okay. Anyway, is there any questions on what we just did? I'm going to show you the answer key real quick. So in the question one, all they wanted was x. This is what we did first. So sine, opposite over adjacent, adjacent over hypotenuse, etc. They chose cosine as well and solve for x. So multiply both sides by 15, which gave us 7.7. Excuse me. but not too crazy, right? Okay, so we did some of these as well. So before I show you the answer, the sun is 60 degrees above the horizon. Find the length of the shadow cast by a building 100 feet tall. So they want us to find this section. So before we start anything or look at it, but what trig function would y'all choose to set this up? 'Cause that's what really matters is do you remember how to set it up?
Would it be sine?
Sine. Well, we don't have the hypotenuse. We have the opposite. Sine, would sine work? Let me see. No, because we want if we use sine of 63, then we'd only be able to solve for the hypotenuse. So we want to use cosine.
Oh, okay.
But I'm glad you mentioned it. Let's talk about why, right? So if we say cosine of 63, that whole adjacent and opposite is relative to the angle that's in here. So if I'm talking about this one, then adjacent's here. If I was talking about an angle over here, then adjacent would be here. So we do have to remember that part. So to solve it, you would just plug in that missing piece over your. Actually, no, I was wrong about that one. So we're both wrong. Cosine doesn't work either. Which one is it? Because I don't have hypotenuse. Do you need one without the hypotenuse? Can't be sine or cosine. Let me see. So it has to be tangent because it's opposite over adjacent. So tangent or cotangent would work. You would set it up this way, which would get you most of the points, right? Because this is shows your understanding. Some basic algebra will get you to 51. But yeah, we have done quite a few of these. Is there any questions on this while we review this? Do you see why we chose tangent?
Yes.
Okay. Okay. So if we want to solve for here, they want to know what the actual angle. That's kind of cool. And what size do we have relative to x?
Adjacent and opposite.
Yeah, we have opposite and adjacent, and they want the angle. So this guy will be opposite when it comes to x. This is adjacent. So since it has those two, we want to choose tangent. That way we don't have too many unknowns. but the x is trapped in there. So what would y'all do to solve for x?
What do we just put in the calculator? The adjacent over opposite?
Well, this one,
Mm-hmm.
if we did, we'll get a decimal, but that would only tell us that tangent x is equal to that. But we want to get rid of the tangent first. How would you get rid of the tangent? 'Cause I need this guy, right? Do you remember back in when we were talking about inverses, when we would cancel the function?
Don't.
Basically, I gotta use the definition or think of it as tangent inverse of both sides. Whatever makes more sense, doesn't matter. And this is the part you punch into the calculator right here. Oops. So x is equal to this. So that implies x is equal to whatever tan inverse of this nonsense is. So make sure you're in degrees and plug it in, and you'll get your answer. Where is it? So hit second and then tangent, and you get the inverse function. Plug in 192 divided by 1066. So it should be 10.2. So let's see with how they did it. So they use the word arcsine, which is the same as tangent inverse. So they kind of skip straight to here and say, well, this is almost like a formula, but they don't really explain anything. So you get here by setting it up the way we did and then introducing the inverse. And that's why we get 10.2. But anyway, does that make sense? Do y'all remember doing stuff like this? Any questions on this guy? Okay, so you guys are good. Alrighty. The number six, basically what we did at the very beginning. So let's do this on paper and then we'll move on to something else. Oh, one. This one. This is number 6. Solve the right triangle. And this is what was given. And they're calling, usually a rule of thumb is capital B is opposite to little b and vice versa. So little a would be opposite to capital A over here. And C in this case tends to be the right angle. So what is A? B, C, lowercase a, B, C. All right. So the angle shouldn't be too difficult, right? A was given. C is a right angle. So what does capital B have to, what is capital B? What does it have to be?
Is it 40?
Yeah. Yeah, looks like it's 40 for sure. Yeah. Okay. We got all our angles. So we can use these angles to help us out to find the sides. We have little c. Okay. If I want to find lowercase b, I guess, how would you set this up? The hypotenuse is 15.
Diagram theorem again?
But we only have one side, so we
Oh, yeah.
can't do it. So we have to use the trig functions. Which trig setup you think? Yeah, we could do sine of which angle?
50?
If we do sine 50, then we'd have opposite over hypotenuse, so we could solve for the A. So that works. So sine of 50 degrees is equal to A over 15. So solve for A. A is equal to 15 sine 50, which is approximately, I don't know, 11.5. Now, if I didn't want to feel like using Pythagorean, what's another trig function we can use to find B? little b. We have capital. Let's see if we're using the 40. Hmm, we could use 10 because it'd be opposite over adjacent, and we have the adjacent, right? Adjacent relative to b. We can. Tangent of 40 is equal to b over a, which is b over 11.5. The only issue is sometimes when you're using a trig function that's been rounded, it could throw off the answer, but it should be okay. So solve for b. Let's find out what happens. It'll be 11.5 tangent 40. What is that? 9.6. So we got all our sides and all our angles. So let me show you what they did. No, there's more than one way to solve these because you can use any trig function. So they started with sine as well. They said sine 50 is a over 15. Multiply both sides by 15 gets us to here. Punch it into your calculator, and that's what we got, right? Then they went a different round and said, you know what? We already have an exact whole number and angle, so we're going to use cosine instead of tangent because this wasn't rounded. So this was better accuracy, but it turns out we both got 9.6, so it doesn't matter. So they said cosine of 50 is equal to b over hypotenuse, solve for b. So any questions on how we or they did it? Now let's move on to the next section then, because I feel like the main idea is, do you remember SOHCAHTOA, sine over hypotenuse, cosines, adjacent over hypotenuse, etc. And then can you solve a right triangle for all the sides and angles given uh, some sides and some angles? If that feels doable, let's move on. That's weird. Oh well, that's fine.